మీ మొబైల్లో చెక్ చేయండి, తెలిసిపోతుంది. Again it is only connecting to the streaming, it is saying, not the confirmation. Click on that. Sir, sound descends. సో అసలు కాదు, ఇక్కడెక్కడో సెట్టింగ్స్ చేంజ్ చేయాలి. ఇప్పుడు చూడండి, నా చెక్. ఆ సౌండ్ తీసేసి చూడండి సార్. Starting, so please confirm this one. I typed some stars going on top of this special learning. Just it takes 2 minutes, then it's a confirmation that is started. Now started up. నువ్వు మళ్ళీ బ్యాక్ వెళ్ళి వెళ్తా మీరు. ఎస్, సారీ గైస్ ఫర్ ద డిలే. Come to this one, from the beginning iteration onwards, here what happened. In the beginning iteration, it has taken random weights. After that, it applies the prediction, calculating the error. To reduce that error, it applied the derivative. Based on the derivative, it modified the weights, then it starts second iteration. Same work from the step 2 to up to step 4, it has repeated, like prediction, error finding, and then derivative. Once derivative applied, again new weights are producing. In this way, some iterations have been completed. Think that after completion of the number of iterations 101, 102, 103, compare the things between the errors about 101 and 102. In the 101 iteration, error is 5. In the 102, the error is 2. So when compared with the previous error, if error got reduced, then it will continue the next iteration again to reduce that error. But here, between 102 and 103 iterations, there is no difference in the error. If there is no difference in the error, or the difference is negligible, very minimal error, then it will stop the iterations. So here I write the statement: whenever current error and previous error both are equal or close together, that means the difference is very, very neglectable. Okay, if the error is that one, whenever current error and previous error both are equal or close together, then learning of the model is completed. then it stops iterations, learning iterations. So in this way the model does self-learning. That means already you know model means math predictive model. Self-learning from data. So finally after coming here, in this case after completion of this one, if you take the predictive equation y equal to x dot w, here y for output label matrix and x for feature matrix. And w, this is called weights matrix. You can say this one as knowledge. In the beginning, very bad knowledge because it has taken random weights, but after completion of all these iterations, okay, it got perfect knowledge. Now training completed, once learning completed, that means from your side that is training, from model side that is called learning. Okay, once training completed, we need to do accuracy testing. So again, for doing the accuracy testing, different approaches. Okay, later once we step into the programming part of this machine learning and model understanding, mathematical model understanding of this one, there we will discuss. Okay, we need to do accuracy testing. For example, the accuracy of my model is 98. That means what? What is the meaning of this statement? Out of 100, 98 predictions will be correct. Predictions are close to real values. Got it. That is real target values. Got it. So now if you are satisfied, about the accuracy of the model, about accuracy of the model, then you can deploy model and model's knowledge into application. Then application behave like human. So without human interference, if you pass any inputs, based on the inputs, automatically your application could able to predict the things. Got it. So this is general style of machine learning. So especially in the machine learning or the neural network, same kind of approach but different layers will be there. In the case of machine learning, your approach simply step 1, take initial weights. So this is before start training. That means random weights it is taken. Step 2 onwards, loop starts. Loop begin. In the loop, your step is, so let's say this is 1. Step 2, train the model. Got it. Loop begin. Here I am going to write sub steps. Step 2.1. Apply the prediction. And step 2.2. Find error. Step 2.3. Apply gradient, that means derivative. Step 2.4, modify previous weights. Okay. then loop ends. So before here one condition it will check. If current error equals to previous error, then exit from loop. That will stop the training. Else continue the training. That means continue training. This is the case. So these steps we need to follow. This is machine learning step. Got it. And come to the neural network, which is next level to this machine learning kind of approach. What is the difference between machine learning and neural networks? In case of neural networks, that means in case of machine learning, first I am going to talk about machine learning. There will be two layers. Observe here, with a pic I will explain this. So in our case, I am taking age, weight and height are input variables. Think that cholesterol is target variable. So your prediction problem is based on age, weight, height. You want to estimate the value of the target variable, which is cholesterol. That means generally one variable you are taking for the bias. Forget about the bias. What is bias you will be understanding in coming mathematical part. The first one is bias. Second one is the variable for age. Next one is the variable for weight. Next one is variable for height. And I have a target. The target variable here, cholesterol. Okay. Now you need to prepare two matrices. One matrix per, suppose X is the matrix per features. Features means input. Y is the matrix for labels. Labels means target variable cholesterol values. Okay. And W, how many weights will be there? This bias is hitting this target. Input variable age with some force, it is hitting the target. Weight also impacting the target. And height also impacting the target. So that means if you talk about the weights, treat it as W0, which is for bias, some hidden force. This is age, weight 1, weight 2, weight 3. In this data, what you know? You know all input features, you know all output values, but you don't know these weights. You don't know. Understand? This weight matrix you don't know. This is simply called as weight matrix, which is W. Treat it as W. What is our prediction equation? Y equal to X dot W. So Y is a matrix, X is a matrix, W is a matrix. From the given data, what you know, what you don't know. You know what is X. That means what are all the input variable values. And you know what is Y. What are all target variable values. But you don't know what is the relationship between them. Here the relationship is by this weight matrix, which is W. But as per our machine learning style, what is the style of here? Style of learning here. First it is taking random weights, maybe some rough values. In the beginning you suppose W0 it is taking as 0.1. W2 0.12, W3 value maybe it is taken 0.003, and W4 value, sorry, W3 value which is 0. Or minus 0.02. Like this it is taken. Initially random weights. By taking the random weights, it applies prediction. The prediction equation here, y equal to x dot w. Now you will get new predictions. So x has input variables, w has weights. X dot w, the multiplication of these two matrices is prediction. But prediction has error. Calculate the error. I got error here 180 as per previous example. This happened in the first iteration. To reduce that error, it applies derivative. Derivative will produce delta. Delta means modifications in the weight. That means these are how much should be modified in the weight matrix. After that, the next step, weight matrix should be updated. W equals to this delta. Of course, there is a learning rate. What exactly the learning rate, I will explain later. There will be some learning rate. Simply the symbol is alpha. Okay, the derivative produce the how much to be modified in the weights matrix. After that, the weights will be modified. After that, again next iteration. Now observe here. Initially, it is taking random weights. That means your journey starting, the learning journey started here. After that, it is applying prediction. Once prediction is done with the random weights, it is applying calculating error. To reduce that error, it is applying derivative. After that, it is modifying weights. With latest weights again training starts here. This is iteration number 1. In the iteration number 2, iteration number 3, for every iteration, this error will be keep on decreasing. But one fine and it will reach saturated point. The current error and previous error is equal or very close together. Then learning, that is the indication, the learning part is completed. Next onwards, how many iterations you run, there will be no improvement. So that means finally here I have 2 layers. What are those 2 layers? Layer number 1 and layer number 2. Got it? Layer number 1 and layer number 2. Between them weight matrix. Understand? This is working style of machine learning. And if you talk about neural networks, in machine learning there are 2 layers, okay, but in neural networks, there will be 3 layers. Okay, there will be 3 layers. Because of 3 layers, more hidden patterns can be found out. Just observe the peak of it. That is, what are those 3 layers? One is input layer, second one is hidden layer, the third one is output layer. The hidden layer means features, input features. Hidden layer means just simply hidden, and output layer is labels. Got it? Just observe the pick of it. Same style as machine learning only, but number of layers will be increased. Here you have only one input and one output layer in the case of machine learning. Okay. Now in neural network, how it works, just a small difference, you just check it. Small change into this one. Let's make the picture big. I have 3 input variables. That's why one bias, 3 input variables. So why bias will come into the picture once you step into the mathematical part of this, you will be understanding. And one target variable. So here the first one is bias. Second one, your input variable age, as per previous example. The second one, your input variable weight. The next one, your input variable, one more input variable which is height. Your target variable is cholesterol. That means you have to prepare two matrices as usual. I will increase the size. X, its feature matrix. Forget about mathematical part and calculations part. I am giving overall idea about that one. Okay, once this overview of all the things completed, we will step into the mathematical part and then how to implement with programming. And Y is label matrix. So only two layers will be there into the machine learning. But here I am going to take one hidden layer. In the case of left as input part, I have 4. General the guideline. I am giving 6. Now observe the forces. So in the previous picture, opposite to the bias there is only one cholesterol. Opposite to the age there is only one cholesterol. Now opposite to the bias there are 6 variables. Bias to first neuron, first cell of the hidden layer, to the second cell, at the same time to the third cell, to the fourth cell, fifth, sixth. Similarly, age is hitting different forces. With the different forces, it is hitting all the opposite targets. Observe, keep on observe here. Same thing, weight. Opposite to the weight, there are 6 variables. That means 6 cells. As per neural network terminology, these cells are called neurons. Similarly, opposite to the height, there are 6 again. That means height is releasing 6 different weights. Similarly, hidden layer to that cholesterol. Opposite to the hidden layer, in its opposite there is only one. That's why these 6 cells will release 6 different weights to this one. This is neural network architecture. Observe here, going with a fresh picture of the same. In my left side I have 4. In the right side I have 1. The 4 is for input, this one for target. Between them I am taking one hidden layer. In the hidden layer I am keeping 6 cells. Okay, here I have 4, that's why making 4 plus 2. There is no fixed rule, fixed count for this, but there is a guideline. What are those guidelines we will discuss later. Now between, this is input layer. The first one is input layer. Second one is hidden layer. The third one is output layer. Come on, in the machine learning, how many layers you have? Only 2. Input and output, between them weights. But now I have 3 layers. Between input and hidden layer, one weight matrix will be there. Let's make it as W1. Between hidden layer and output layer, one more weight matrix will be there. Let's make it as W2. Understand? At each layer, one predictive function will be applied. At hidden layer, predictive function. At output layer, one more prediction. Now observe here, weight 1. What is the matrix size? 4 rows, 6 columns. 4 rows, 6 columns. How it is possible? Because the bias is releasing 6 weights. Input variable age is hitting opposite layer with 6 weights. In the left side I have 4, right side I have 6. So that 4 by 6, 4 rows, 6 columns matrix. Similarly, W2 is a weight matrix. W2 is a weight matrix. 4 rows, 6 rows, 1 column. Got it. Initially it is taking random weights. In the step 1 it is taking random weights here. Observe the flow. In the beginning random weights. After that it is applying prediction. On that prediction, based on that prediction, it computes error. Okay, before that error, the process, the life cycle is completely different. A little, don't get confused, just in a high level try to understand this concept. First it is taking random weights for the W1 and random weights for the W2. Got it. By taking first random weights, it is applying the prediction. This layer output is input to next level prediction. By taking these two, by taking this one and this one, the output of previous layer is input to this output layer, third layer. Understand? Sir, after first layer, one output is applied. This is first layer. By taking these two, which one? By taking this input and this weight matrix, here prediction is happening. Okay, now in the hidden layer, output of these two. Got it. Output of these two will be there. Got it. By taking these two, because what is the input for this output layer, third layer? Output of hidden layer. Got it. Output of hidden layer. This output is input to the output layer. Hidden layer output is input to the third layer. By taking this matrix and this weight matrix, again it applies prediction. Then it calculates error. Think that I got error 290. This error because of what? In this moment, this error because of what? This weight to matrix. After that, it applies derivative. It applies derivative. The derivative produces adjustables. That means it produces delta. The delta will be modified. Where is that? Based on this derivative, how much should be updated to the W1? That will be calculated. Once that part is calculated, it modifies the weights of W1. Understand? And modifies the weight of, and it finds how much should be modified to. 1 minute, here it is not displaying. How much should be modified to W2. Okay? So once weight 1 is modified, by taking the new weights, again it is applying prediction. Now fresh output will be produced at a hidden layer. Again with fresh output and with fresh W2, again applies the prediction. And immediately computes the error. This time error will be definitely should be less than 2 Previous error, maybe 100. In this way, iteration number 1, iteration number 2, the journey will be going like this. So previously some complex patterns cannot be identified because of more hidden layers. One of the hidden layer involvement and more weights. Because of the more weights, it learns more knowledge. In the case of machine learning, how many weights? How many weights? In the case of machine learning, I have 2 layers. 1, 2, 3, 4 and 1 target. So how many weights here? Weight 1, weight 2, weight 3, weight 4. How many weights here? 4 weights. In case of neural network, how many weights? In the W1, 4 into 6 means 24. In the W2, 6 into 1, that means 6 weights. Total how many weights? How many weights here, sir? 24 plus 6, sir? 30. But here in the machine learning style, how many weights? Only 4 weights. So where is more knowledge about the data patterns? At neural networks. Because of only 4 weights, less knowledge. Because of 24 plus 6, 30 weights, more knowledge is there. Got it? So how to calculate these estimations, how to calculate this error, how to apply this derivative, for now just simply forget. Okay, because till now we did not step into that mathematical part of it. So here simple understanding. One example I am taking here in machine learning style. We have 2 layers. Suppose A is weight, height are inputs. Cholesterol is target. So input matrix X, in label matrix Y, weight matrix. Totally how many weights? 3 plus 1. 3 for slopes, 1 for bias. Totally 4 weights. Got it? So what is slope, what is bias? Later we will discuss. Okay, same thing in neural network style. In neural network style, I am going to talk about this style, neural network style. Come on. How many layers? Input layer. How many cells here? Bias, age, weight, height, as per our example. Hidden layer. So that means here how many cells? 4 cells. Right? Treat each cell as a neuron. What is this neuron? What is the functionality of it? Later we will discuss. I am going to talk about hidden layer now. In hidden layer, I am going to keep 4 plus 2 cells. That means 6 cells. And one output layer, I have only one target variable. Even you can have multiple target variables also. I have only cholesterol here. That means 1 cell. Right? Now, weight 1 is weight matrix. Between what? This input and this hidden. Left side 4, right side 6. So that what is the matrix size? 4 rows, 6 columns. Got it. Between input layer and hidden layer. The matrix size 4 rows, 6 columns. That means 24 weights. and weight 2. What is weight 2? Is a weight matrix between what? Hidden layer and target layer. That means output layer. What is the size here? Just by seeing this peak, you tell me. 6 in the left side, 1 in the right side. So that what is the size? 6 rows, 1 column. Okay? Is 6 by 1. Total number of weights. 24 for the first layer. For the W1, 24. For the W2, 6. 24 plus 6, 30 weights. Understand? So observe here. In our case, in our above example case, in ML, we got 4 weights to the above example. But in NN, we have 30 weights. So where is more knowledge? More knowledge at? Yeah. Understand this part? On that way, deeper hidden patterns also you can identify. Got it? Suppose from 100 feet distance or 200 feet distance, I see one person. The person looks like a girl. I assume him as a girl. But when he come to close to me, in fact he is not a girl, he is a man. So why this kind of wrong prediction happened? Some hidden patterns, the similarity between that male and female is very close together at that boy case. Got it? That's why I failed it. So machine learning will be generally with the 2 layers that will be failed at that kind of complex situations. Then you have to come to neural network. If more commonality existed, come to the neural network. Generally up to 60% commonality or 50 up to 60% commonality, the machine learning is able to do that one. If commonality between 2 classifiers, that means 2 target categories between male and female, okay, the category is very very close together. The commonality is more high. Generally we confuse.